I'm going to talk about CoffeeScript, which is a little language that is written in itself and compiles to JavaScript. So I was pretty interested in a lot of what Crockford was just saying a couple minutes ago over in track A about all of the sort of deficiencies and things that people aren't satisfied with in JavaScript and things that could have been done better, bad parts that should be left out. And it should be kind of like a human right, but for coders, that you should have a coder's right to have JavaScript be the language that you want it to be. And because JavaScript has such a nice, clean, functional, object-oriented, lexically scoped core, you can build a lot of interesting languages on top of it without having to get too far away from what the core idea of JavaScript is. So could I get a quick show of hands of how many of you have played with CoffeeScript before? All right, so that's a pretty good mix. So I'm going to go quickly through some of the language features, what it does differently than JavaScript, and then also how it's implemented if you want to write something like this for your own language that would be however you saw fit. So let's see here. This talk is going to be pretty rapid fire. It's also just going to be all code. So we can, if you have any questions, feel free to raise your hand in the middle, and we can change things and recompile it and see how it works. So there's kind of three main aspects to the idea of doing this. There's a lot of languages. I mean, I guess one of the other really big ones is Objective-J, which puts Objective-C into JavaScript. But to do that, you have to have kind of an entire runtime. But the idea here is not so much to port an existing language like Python or Ruby into JavaScript directly, but instead to take the core of JavaScript and to clean out all the syntax that looks like Java but you don't really need, and to also clean up some of the semantics. So things like var, how you have to use var the first time you declare the variable, never again thereafter, and you almost always need to use it the first time because you don't want it to be global. So things like that go away. Things like statements go away. Everything is an expression in CoffeeScript. So you can pass the result of an if statement directly back to, you can assign it to a variable, you can pass it back to a callback, that sort of thing. So that's the second aspect. We have the cleaned up syntax, we have cleaned up semantics, and there's also extra goodies. So language features like slices, splats, that's the variadic arguments that Crockford was talking about before. You have comprehensions instead of low-level loops, and all kinds of extra goodies that we can. There's some things that you can't do, like Brian was just talking about, like with method missing. You can't do that without actually either having an interpreter or having, or intercepting every single object call that you ever do. So those kinds of, there's some things that are just impossible, but the things that we can do, we try to. So so that brings us to the golden rule, is that it's just JavaScript. It's not a runtime. It's not an interpreter. There's no special functions really allowed, and that's a rule we break slightly. But we're not going to be injecting a whole bunch of CoffeeScript-specific library functions into your code. In general, it just translates into the equivalent JavaScript. So it leaves a lot of things out. It is a smaller language than JavaScript is. You don't have with, you don't have semicolons or semicolon insertion to deal with in your parsing. You don't have to worry about trailing commas. There's no difference between the colon inside of the object to assign a property versus variable assignment outside, syntax-wise. No implicit global variables because that's taken care of for you. You don't even have to worry about low-level for loops because instead you have comprehensions. And if you really, really need the low-level loop, you can use a while. So that's the one that we do expose, and that's general enough to be transformed into anything else. And no difference between ternaries and if-elses, right? So in JavaScript, you have an if-else that's a statement. You can't return that value. But a ternary is an expression, and you can. And there's no real reason that they need to be two separate things. So let's start with the basic, basically a function. So here you have a JavaScript function. It's assigned to a variable named square. It's also named so that if you need to debug it, you'll actually have a name and won't just say anonymous. And you're going to return, you take in a number x, you return x times x. And that's JavaScript 101. So if we were going to transform this into CoffeeScript, what would that look like? Well, first off, you don't need the semicolon because why bother? Second, you don't need to declare your var. You can just assign it. We can use, and this is kind of up to your style. The preferred CoffeeScript style is to use colons to assign all over the place instead of equals, but they are interchangeable. So you can use equal signs instead of objects, inside of objects as well. So we'll switch this over to a colon. Returns are implicit inside of a function. The last expression you evaluate will always be returned, so you don't need to return it yourself. So we'll take that out, and also the semicolon in there. It uses Python-style block whitespace syntax, so you don't need to use curlies to delimit your blocks. So we'll take off the curlies and just use the indentation there. And finally, instead of the function keyword, well, I guess before we get to that, we have square repeated twice, and which always looks very redundant. So let's take off one of those squares. And finally, instead of the function keyword, what a function looks like is just an arrow pointing from the arguments to the result. So we have square is a function of x, and it goes to x times x. And now that's highlighted as a function, and you can also write that on one line like this. So you can see how that got transformed. Square is a function that takes in x, and it returns x times x. So that's a good example. And actually, let's give this a try. So this TextMate is hooked up, and there's a TextMate bundle, there's an Emacs bundle, there's a Vim bundle, there's bundles for all your needs. This one's hooked up so we can compile this and see what it turns into. So here we have it back looking more or less like it did. The declaration got pushed up to the top, but you have back your JavaScript function, and if we run that, let's say puts the square of 100, and we get, oops, I have to do the whole thing. Let's do this. We get back 10,000. All right. So the MO is to not change anything about JavaScript that's already very clear and very common. It's not just changing it for change's sake. So arrays look the same. Object literals look the same. Those are both very nicely done. You can see how we're using the same assignment syntax. Elements is an object literal that has hydrogen, silicon, and uranium properties. Because we are whitespace sensitive, if you do your assignments on multiple lines, you don't have to worry about commas. You can leave them off. You can put them in. You can have trailing commas. It's all going to compile to the same thing. So actually, let's do that. We compile this to JavaScript, and we'll get our commas. And you can see, even if you have them and it's trailing, it's not going to be trailing when you compile it to JavaScript. So IE won't kill you on that. And property accessing is the same. It's dot properties, so we can say puts elements dot silicon, and we're going to get back 14. All right. On to the next one. So this is the white space for block syntax that I showed you before. It, of course, looks more Python-y when it gets more nested. So here's an if. Here's a block if statement. If answer is yes and attempts is less than 3, then we have a try catch. Try again, catch error, report error. And if we look at what this compiles to in JavaScript, just to get a sense of how the white space is working, it's going to look like this. So you can see how your try-catch block got translated and all the curlies got inserted. And this also shows some aliases that you have. So all of the JavaScript operators, greater than, less than, triple equals stuff is available, but you also have aliases. So yes, no, on, off are aliases for true, false, like they are in YAML. So you can write things out a little bit more naturally depending on what your wording is for your Booleans. And then also is and isn't for triple equals and not triple equals, which is nice too. So a lot of things that are available in block syntax form like this are also available in postfix, prefix or postfix. So here we have if ignition is on, block launch rocket, or you could say launch rocket if ignition is on. And if we compile this snippet right here, we can see that, I guess in one case it became the ternary, in the other one it's the actual block if, but they're doing the same thing. If ignition is true, then you launch the rocket, otherwise you don't. And then the same thing is true for basically for anything where you have an indented block. You can also do a prefix if it's just a single line expression. So here we're doing a comprehension. So for every song in repertoire, we're going to sing it, and then this is the same form, but written out as a block. All right. So getting past the sort of the syntax subtractions, all the semicolons and punctuation noise, towards the expression stuff, which I think that everything's an expression is probably the single most important feature of all of this. It definitely changes the most in how your code is structured. So here we have a comprehension. You're going to print out I for I in that array in 1, 2, 3. And so this is an example of running a function call, n times or I times for that entire statement. So if we run that, we're going to get 1, 2, 3. Oh, I just ran the entire file, sorry. We're going to get 1, 2, 3. But you can also, so if you wrap the comprehension in parentheses, or if you call the comprehension, or you return it, or you assign it to a variable, it's going to be converted into an expression for you. And so what that means is that as we're generating the code, we look at the comprehension and we say, is it being used? Is it being returned? Is it being assigned to? And if it is, then it gets converted into the result of the computation every single time through the comprehension. So this just should be familiar to you if you've used Python before, or but it's basically the equivalent of doing an each or a select or a filter. So you are taking, you're applying the block of code for every time through the loop, and then you're taking the array of results and you're returning that array. So here we're going to print out 1, 2, 3 as an array. I guess P will make that more clear because P will inspect that. So now we'll see 1, 2, 3 as an array as the result of this. And so internally what it's doing is it's pushing the result of every time through onto an array and then returning that when it's done. But this works exactly identically for anything else. So here we're going to put a try-catch block directly into puts. And so if we run that, we're going to try to call a property on a missing object. This object is not defined. It doesn't exist. And then catch the error and then print that out. So we have the error is reference error, missing is not defined. And so internally what happens is basically every single node in the grammar knows how to return itself. So you can ask it to, basically if you're an if, and you're being asked to return, it'll return from any of the branches that it goes into. If you're a for loop, I mean, if you're a comprehension, you're asked to be returned, you're going to return the result of going through the array. If you're a try-catch, you're going to return either the try or the catch, depending on what gets fired. And so based on that, anytime you need to convert an expression, a JavaScript expression, into a JavaScript statement into an expression, you can wrap it in a closure. So if you wrap it in a closure and then you return the result, now you have something that used to be a statement, but instead it can be used as an expression. So that's what's going on internally there. The other thing that I didn't mention that this demonstrates is this isn't being syntax highlighted in this, but we have string interpolation as is proposed in ECMAScript Harmony. One really fun place to mine for language ideas is there's an ECMAScript Harmony wiki that has a whole bunch of things that they're thinking about putting into the next version of JavaScript, and this is one of the proposals. This is just a quick little demo of how the var works. So you might have noticed that we're not declaring var at all. But what ends up happening is that when you first use a variable, when you first assign to a variable, its var declaration is going to get pushed up to the top of the nearest lexical scope. So in this case, A is going to have the equivalent of var A out here because it was first, even though it's being referenced in the same exact way inside the function, it was first referenced outside. And then B will have a var B inside the function and won't be visible from the outside scope. So that's how that's handled for you. What it means is that you can't shadow variables inside of a function of the same name. You're always going to be referring to the outside variable. And that's similar to languages like Ruby inside of blocks. If you refer to a variable of the same name, it's always going to be the outside one. So you have to pick a different name if you actually mean a different variable because there isn't a var for you. And I think that's a worthwhile trade-off. The other way isn't workable at all. If everything shadows, then you can't get anything done. Here's another example of a cleanup. We fix JavaScript switch statement. So I guess we should have a longer example of what it looks like. These are the same sort of implicit blocks. You can say when mo, then do an action, or you can indent it like this is equivalent. But switches internally compile into if-else chains using object identity to match instead of a JavaScript switch case statement. Because JavaScript switch cases are implemented using labels, you can only do string comparisons. You can't compare anything that's not a string, and if you do, it'll coerce it. And then also you have to stick in break after every case if you don't want to fall through. So instead of doing that, this becomes an if-else. So we can let's put this back the way it was and give it a try. So if we run this, actually nothing will happen. So then let's call, so which stooge is a function that switches on stooge. When it's mo, then it says it's mo. When it's curly, and this is using actual objects, not strings. So let's say put switch stooge curly, and let's run this file, and we'll have it's curly. Oh, I'm sorry, it was already putzing. We can just say which stooge curly. We can do the same thing for mo. And let's look at what it compiles into. So we have our two objects, and you can see how we have our function. It's a named function. If Stooge is Mo, then we return that value. You can see how the returns are getting pushed into each statement. So because the switch, that's a good example, because the switch was the last thing that happened inside the function, you're always going to return a value no matter what you do. Let's see, it's 1022. All right, here's that string interpolation. So we have $, and so this is exactly the same as the proposed harmony syntax. $literal, or you can do literal.property, just gets interpolated directly. And then you can, with $ with brackets, you can do arbitrary expressions inside of your interpolation. So let's say Jeremy. Name is Jeremy. There you go. And one thing that we add is Python's chain comparisons. So if you have more than one greater than, less than comparison in a row, it's going to do the correct order of operations to make that value work. So healthy is if your cholesterol is less than 200 and more than 60. So healthy 133 is going to be true, and healthy 40 is going to be false. And what's going on under the scenes, behind the scenes here, is this gets converted into 200 is greater and cholesterol is greater than 60. And so this is one of those cases where if you're doing something like this in your own language, you have to be careful. If you ever have to reference a variable multiple times to compute a result, you have to be careful that you don't call, for example, if what's going on here is a function call, that you don't call the function twice, because then that could have side effects and could do something you don't want it to do. So the way we get around that is if cholesterol is actually a function call here, and you compile that, what's going to happen is you're going to get a temporary variable assigned to cholesterol and then referenced in the later one, so you don't have to, so it doesn't get called twice. And that's the case in general for something where you need to have multiple references to an expression that you don't want to evaluate more than once, is we'll do a temporary variable in the output JavaScript. So really quickly, besides, we saw the array comprehensions before where you're saying I in a list of numbers, but you can also do it for objects. So for number in a list of numbers, or for key, value of an object. So in this case, we're going to look at all the keys in, this is all being powered by Node.js on the back end. So we're looking at all the keys in the process object, which is one of the global objects that you have. And you're going to get back your big list of Node signals and such. And so that's an object comprehension. And of course, you can have a block inside of that doing however much code you need to do. And then there's also range comprehensions. So instead of having to write out, if your for loop was just going to be numbers, and you're going to start at 0 and go up to a certain amount, instead of that, you can use a range literal. This is the same as Ruby's range literal, more or less. So 2 dots is inclusive of the final value, and 3 dots is exclusive. And so this is going to be the comprehension of I in 0 to 20. Let me take off this by 2 for a minute, and then we're going to join it. So there you have from 0 up to 20. You can do steps, so we can say by 2, and that'll give you the even numbers. And you can also do filters. So this is where that select filter kind of thing comes in. So for any comprehension, you can say when, and then you have an arbitrary condition to satisfy. So in this case, let's say when I mod 2 is 1, and we'll get all the odd numbers. Or how about this? When I mod 2 isn't 0. Isn't 0. And now we get all the odd numbers between 0 and 20 inclusive. All right, I'm going to try to get through this on time. So here's a JavaScript statement again. You can tell because of the semicolon. So this is something you've probably done a lot, where you have a default value you want to assign to a property inside of the beginning of a function. So one of the simplifications that we do, you know how you have plus equals and minus equals and divided by equals in JavaScript. And in languages like Ruby, you would have, instead of writing this, you would write or equals to say that the options or equals the default value. So one thing that we do to get rid of those, you can still use those if you want to. They're present. It's all sort of backwards compatible with JavaScript. You can sort of slip into it easily. But the cleaner way to say that is just assign it to the half expression. So options.value gets or the default value, or you could do gets and, or you could do gets plus. And this would be like doing a plus equals, assigning it to plus the default value. So let's talk about splats. Splats are a nice feature where, if you have a splat in your argument list, we'll compile that into the correct lookup inside of the arguments array to get back what you need. So here we've got best actor. The first argument's going to be the winner, and then every next argument's going to be a runners up, and we're just going to print out who the winner is, and then pass in three actors, and you'll get the expected result. And if we look at what that compiles into, you're going to see that we're going to be, so this is one example where we do have a reference to a special function just to keep the code shorter, the actual outputting bytes. So we make a cache reference to array prototype slice, and we're going to slice the runners up to get that. This is kind of a fun one. The existential operator. Or the logical or. There's a lot of falsy values in JavaScript, things that like 0, the empty string, that might be confusing to you. So if you're trying to set a default speed, for example, and you use or, if the speed happens to be 0, which is a perfectly valid speed to have, it's going to still get the default, which isn't what you want. So what you really want is you want to say, if it's not undefined and it's not null, those are being the not exist values, then use it. So the existential operator, which is the question mark, gives you a way to sort of to say if it's undefined or if it's null, then do one thing or else do the other thing. So in this case, if we leave this the way that it is using or and run that, you're going to get back 140. Let's see. I need to run just that part, right? You're going to get back 140. But if we use the existential operator, you're going to get back the correct value, which is it's going to stay 0 because 0 is a valid speed. And so you can use the existential operator within a property chain. If you're walking down a property chain, this is similar to a soak in Groovy, where if that value is undefined, that property is undefined, then it's going to stop, and you're going to get back undefined as the result. So in this case, we can say put Sue.name. Let's get rid of this. And it's going to say Sue. Sue.name.length does exist. Sue.name.length.other does not, and we'll get back, let's see, let's keep going. Other.1.2.3, spelled wrong. You get back an error. But if you want to soak it up and you want to assign, this often happens, and you want to assign, if it doesn't exist, then just give me back undefined, and I don't need to continue. Then we can say, oh, let's soak up the result of that chain after other. And you're going to get back undefined instead of the big exception. So yeah, a judicious use of soaks can help clean up your accessing. And I'm going to try to wrap things up. There's class literals, which this is basically a lightweight wrapper around. So this isn't like a full-blown class system with runtime objects and stuff. All this is setting up. Is basically you have an object literal and you set properties on an object, right? You have a class literal, you're setting objects on the prototype. You're setting properties on the prototype so that when you make a new object, everything will be set up for you correctly. And so the two extra things that this lets you do that aren't so easy in JavaScript is it helps you correctly extend the prototype chain. There's a lot of ways to incorrectly extend the prototype chain where you're breaking your inheritance and you can only get one level deep. But this uses something similar to goog.inherits from the closure library, if you guys have ever checked that out. To basically, you can have arbitrarily long inheritance chains with everything working correctly, including super. So you can call super and it'll reference the function of the same name on the immediate ancestor. And you can, of course, pass variables to that and do the super things that are usually tricky to do without a class library in JavaScript. So here, let's say, so here we've got a sea shanty. Our mariners, we're going to make a new mariner and have him sing. Make a new sailor, and we can see how sing is overridden. This is all, OOP 101. And then the pirate calls super and then says R. So we'll have the pirate sing. And that's all as expected. And let's see, I think that's getting close to the end. I'm going to wrap things up. So in terms of implementation, this CoffeeScript was first written in Ruby. It was a Ruby gem because, of course, when you start working on a new language, you have to start with something. But now it's written entirely in CoffeeScript. So there was a point where we had a working Ruby version and then wrote a CoffeeScript version that was more or less parallel, had the Ruby version compile that, and then had the CoffeeScript version compile itself. And then now that's where we are. So it's like, I guess there's that Wittgenstein saying about pulling up the ladder after you. You know, we can't go back now. If the CoffeeScript interpreter disappears, then there's no way to compile it at this point, because that's all that does it. So so it was using Ruby and Rack is it's a Yak style LALR parser generator that's done in Ruby and C. But so now that we're in JavaScript, it uses JSON, which Zach is going to give a talk about shortly. I think it's not the next one, but the one after this, which is a nice flexible JavaScript parser generator. So that's the current mix. It's got a handwritten lexer done in CoffeeScript. It's got a rewriter. So the token stream gets rewritten before it actually gets sent to the parser, which is something that lets us go beyond the sort of basic LALR grammar, where doing stuff with the implicit calls, where you can see how we're saying, you know, we have calls that don't need parentheses, and then they get matched all the way down to the end of the block. Doing things like that with the significant white space. And also the rest of the language features gets a little bit tricky if you're trying to fit that into, you know, this would seem like it would be a very large language to try to fit into a grammar. But if you rewrite the token stream in advance to remove ambiguities and things that would be ambiguous, if you decide in advance, oh, this is the way that implicit calls work before the parser ever sees it, then you can have a much smaller parser. So including the grammar, including the rewriter, including the lexer, it's 1,800 lines of CoffeeScript. So it's not very big. And then the result of the parsing stage is the AST, and then to generate the JavaScript, you just call compile at the top level of the AST, and it all walks down, and every node, you know, passing information around, compiles the resulting JavaScript output. So all of this is available on CoffeeScript.org. It is sort of a fun project. It's not supposed to, you know, I'm not trying to sell you on using it for your next big web app. I think it's fun to play around in. And the language still might change until we go to 1.0. Things have settled down a lot recently. It used to be much more unstable. The first version didn't have significant white space, and then people were, you know, talking about it, and we decided to add it. But so the language might still change, and that's the caveat. But besides that, it is being used. Some people are using it in production to do different things. Here's a fun example of someone who's using it to generate art on their website. So this is using CoffeeScript and Raphael to combinatorially combine a whole bunch of little sketches that he has going on. And then I've got a fun example of this of my own, which is right here. So this shows that you're not going to really lose any speed from what JavaScript would be doing if you do something in CoffeeScript, because it's going to be a one-to-one translation. So this is V8 powering a strange attractor that we can, let's see, we can reseed and draw in different ways. And the processing speed of V8 here is very good. It's comparable actually to the Java processing versions of this same sketch. So again, it's all on CoffeeScript.org. There is an interactive compiler. You can try. It'll compile as you type. Right here, it's running in the browser. There's also the entire annotated source right next to that. So if you want to read what the grammar looks like, you can pop over to that, and you can check out what all the rules are. So here's statements, expressions, all this kind of stuff. And come talk to me about it after if you have any more questions, and thanks a lot.